Alright, so we went over this in class today, but I wanted to review this with you again. We can determine the number of roots using the discriminant. So the discriminant is from the quadratic formula, and it's the part that is located underneath the square root symbol. So the discriminant is b squared minus 4ac. So as a quick review, when the discriminant equals 0, there's a double root, which means it's the same root twice. It's what we just did. It hits the x-axis once. The root is the same as the vertex. When b squared minus 4ac is less than 0, it means that there are no real roots because the roots are imaginary, which means that the graph does not touch the x-axis at all. So we would say there's 0 real roots. Okay? And when b squared minus 4ac is a number greater than 0, there are two distinct roots. That means the parabola passes through the x-axis twice. Now, when we get a problem like this that says the following equation has a repeated root, find the value of k. Well, a repeated root is another way of saying a double root. So all we're going to do is we're going to basically write the discriminant using the values here. So a is going to be 1, b is going to be 3, and c is going to be negative k. So I'm going to say b squared minus 4ac. And if it's a double root or a repeated root, it has to be equal to 0. So we're going to figure out what k has to be when we have this case. So b squared, that would be 3 squared, minus 4 times 1 times negative k, has to equal 0. So let's go ahead and find out what k is if we want it to be a repeated root. So simplifying this, we get 3 squared is 9, negative 4 times 1 times negative k is positive 4k equals 0. I'm going to solve for k by subtracting 9 from both sides. So 4k equals negative 9, divide by 4. So k has to be negative 9/4 if this equation is going to have a double root or a repeated root. Alright, moving forward, let's try one more. This one says the equation below has 2 roots. Deduce as much as you can about k. So I'm going to go ahead and write that a is 1, b is 3, and in this example c is positive k, not negative. So again, I'm going to say b squared minus 4ac. If I have 2 distinct roots, I know that this value has to be greater than 0. So we're not getting a single number out, we're going to be getting a range of possible values. So b squared is 3 squared minus 4 times 1, and c is k, is greater than 0. So we had 9 minus 4k is greater than 0. So I'm going to add 9 to both, I'm going to subtract 9 from both sides. I have negative 4k is greater than negative 9. Now remember, when we divide by a negative, our sign changes direction. So k has to be less than 9/4 in order for 2 real roots to be present. If k is greater than 9/4, that means that we are going to have no roots because they'll be imaginary.